We often think AI is intelligent because it can generate language, right? But the truth is, it acts intelligent because it can retrieve, store, and reason over information. For the last 60 years, a war has been raging for control over the machine's memory. And today, the outcome of that war literally determines how AI thinks. This quote, it really gets to the heart of it. The whole idea is actually pretty simple, but it's incredibly profound. An AI's real intelligence is directly tied to its memory, its ability to get information from its database. The better the memory, well, the smarter the AI. It's as simple as that. So, the story of this memory really begins with SQL. You've got systems like Oracle and Postgres. They're the oldest and, frankly, the strongest pillar of the machine's mind. And their job is to do one thing above all else: store the unchangeable facts. We call SQL the truth layer. Think about it. It's all about structure, consistency, and being able to audit everything. Now, it has no idea what any of the data means, but it will absolutely 100% guarantee its correctness. That factual accuracy is the bedrock that all of AI depends on. So when you ask an AI assistant for your exact account balance or the price of something down to the cent, it's not guessing. No way. It's firing off a query to a SQL database. These are the kinds of questions that demand perfect, factual answers. There's just no room for interpretation, only for the verifiable truth sitting neatly in a structured table. The best way to think of SQL is as the machine's perfectly organized filing cabinet. When an AI needs to find that one exact, undisputed truth, this is exactly where it looks. Everything has its proper place, and every fact is right where it's supposed to be.
Okay, but facts alone aren't enough, are they? An AI also needs all that messy, real-world context. We're talking server logs, user click histories, complicated metadata. And this kind of stuff, it just doesn't fit into SQL's neat and rigid tables. And that created a huge problem.
And the solution to that problem? Well, it was NoSQL. Systems like MongoDB and Cassandra, they became what we call the experience layer. Their whole purpose is to capture the world as it actually is, unstructured, chaotic, not how a predefined schema says it should be. This is where an AI goes to understand behavior and find patterns. So if SQL is that perfect filing cabinet, NoSQL is the machine's junk drawer. And honestly, it's the perfect metaphor for the trade-off. Sure, you can throw anything and everything in there, but finding it and making sense of it later, that becomes a massive challenge. It stores the experience, but it can't really make sense of it on its own. And this is what created the central conflict. You have these AI models, like the LLMs we all use today, and they are built from the ground up to understand meaning and relationships between concepts. But their memory systems, both the perfect filing cabinet and that chaotic junk drawer, they just couldn't do it.
I mean, try asking a traditional database a question like this. You're not asking for the literal word happiness. You're asking for related concepts, things like joy, contentment, bliss. This is a semantic question, and for these older systems, it was just completely impossible to answer.
And the failure was just stark. This inability to process meaning created this critical gap in what an AI could do. The brain could think in concepts, but its memory could only think in exact matches. It was a huge disconnect. Let's take a closer look at that failure. You ask SQL to find documents that are similar to a paragraph, and it just has no way to do that. It fails. You tell NoSQL that happy is related to joyful, and it just sees them as two totally different, unrelated strings of characters. They both fail because they can't search for relationships. They can only search for exact data. This massive gap is what sparks the next revolution. This is when vector databases like Pinecone and Weaviate showed up, and they changed absolutely everything. A completely new kind of memory was born. So welcome to the semantic layer. This is a memory system that's designed from the ground up to understand similarity and context. And how does it do it? Well, instead of storing words, it stores their meaning as things called embeddings. Just think of it like this. Every concept gets a specific point on a huge map, and concepts with similar meanings, they get placed close together. These points are basically their mathematical coordinates. So how does this actually work? It's really a three-step process. First, concepts get converted into those coordinates on the map. Second, concepts with similar meanings, like happy and joyful, they land right next to each other. And this is the magic part. Third, a search doesn't look for an exact word.
It looks for everything within a conceptual neighborhood. And that's the absolute perfect metaphor for it. A vector database is the machine's map of meaning. It's not a dictionary. It's more like a GPS for ideas. It lets an AI navigate this entire world of concepts just by looking for what's nearby, not just what's identical. It's a game changer.
So, who won the database war? Well, the answer might surprise you. Nobody. The future wasn't about choosing a winner at all. Instead, the most powerful AI systems today, they don't pick one database. They use all three together in this incredibly powerful alliance.
This alliance is managed by a process you might have heard of called Retrieval-Augmented Generation, or RAG. When you ask an AI a question, it kicks off this amazing four-step dance. First, it pings SQL for the hard facts. Second, it pulls all the messy surrounding context from NoSQL. Third, it does a vector search to find anything semantically related. And finally, the LLM takes all three of those sources and synthesizes them into one single cohesive answer. And this brings us to the core thesis of it all. A truly complete AI memory system is basically a triangle. You absolutely need the reliable, structured facts from SQL. You need the messy, real-world context from NoSQL. And you need that deep, relational understanding of meaning that you can only get from vector databases. The most crucial point to understand is that this was never really about replacement. It was always about augmentation, and the proof is right in front of us. Today, every single major database provider, from Oracle to Postgres to MongoDB, is racing to build vector search capabilities right into their platforms. The future isn't replacement, it's integration. So here's the big takeaway. The history of databases is really the story of building a better memory for machines. Just like a human brain, a modern AI relies on these different types of memory all working together. SQL provides the unshakable truth. NoSQL provides the rich, worldly experience. And vector DBs? They provide that intuitive understanding of meaning that connects everything together. But here's the thing. This landscape is always shifting. As all these different memory systems continue to merge and integrate even further, that leaves us with one final question. Which approach, which database, do you believe will ultimately dominate the next decade of artificial intelligence?